Hello, my name is Kohei Hanaoka. Today I will talk about the topic entitled Measuring Motion of Deformed Surface for Soft-bodied Robots Animals with Multicolored Markers. Here is the outline of this presentation. First of all, I will show you the demonstration of the proposed method. Then I will explain the design and algorithm. After that, I will show you the experiments and its results and discussion. Next, let me show you 3 applications. Finally, I will conclude the presentation and talk about the future work a little bit. First of all, let me show you the demonstration. The proposed method measures the shape of deformable materials using the multicolored markers and the image processing algorithm. The multicolored marker has a simple design and the camera used is a regular RGB camera, so it has the advantage of being low cost. This slide describes the design of the multicolored marker. The features are a saddle shape with triangular faces of red, blue, green, and yellow. These triangles have the same area and are tilted 20 degrees in different directions based on the bottom face of the marker. The area ratios of the visible areas of the 4 colors change depending on the direction the marker is facing. Therefore, the direction of the marker can be estimated from its color area ratio. Let us define the 3 angles of the marker. First, let bar phi is the direction of rotation with no change in color area ratio. Secondly, theta RB is the direction of rotation in which the area ratio of red to blue changes significantly. Finally, theta GY is the direction of rotation that significantly changes the area ratio of the other colors, green and yellow. Next, we will explain how to obtain the angles from the color area ratio. It is challenging to generalize this relationship geometrically. Therefore, we make these polynomial approximate formulas to measure the angles. We rotated the marker model in 3D CAD to simulate how it would look on the camera, which defines the parameters P and Q. The following 2 approximate formulas for calculating the angles were obtained based on the data. Earlier, we defined 3 angles for the multicolored markers. However, the angles must be converted to 1 relative to the world coordinate system. The figure shows how markers facing in various directions would appear to a camera. Focusing on 1, the marker faces to the camera. The areas of 4 colors are equal in the camera view. The 3 angles defined are angles to a plane perpendicular to the direction vector from the camera to the marker. So they must be converted to those for the world coordinate system. The direction vectors from the camera to the marker can be obtained from the following equation using the camera's view angle, image size, and the marker's position on the image sensor. Now we will explain how to estimate the shape. Let us assume that the target is a light blue object as shown in the figure. In this case, the angle and direction of the position can be estimated from the attached multicolored markers, but it is not possible to determine the position from the direction. In other words, we need to determine a point on the purple dashed line. To this problem, we use an AR marker whose angles and positions can be determined. The assumption is that the distance from the intersection of 2 adjacent surfaces to each marker is equal. An intersection line appears between 2 surfaces with different angles. We add the condition that the distance from the intersection, both markers on each side is equal. As a result, the position of the multicolored markers can be determined. This condition is applied to all markers. You can see that the estimated shape fits the target nicely. So why this solution applicable? This time, only three multicolored markers are used for illustration. In reality, we expect to use many more markers. As a result, the intersection converts to the solution-like conditions. Let me explain the setup of the experiment to verify the accuracy. The camera used was the one built into the smartphone Google Pixel 5. Measurements were compared to a high-precision motion capture system. The verification includes angles of the multicolored marker and the relative position of right edge to the left edge of the target when estimating shape. I will show you the results of the angle verification. From left to right, the graph are roll, pitch, and yaw. The horizontal axis is angle from the motion capture, and the vertical axis is angle from the proposed method. These results shows the average error is about 2 or 3 degrees. To improve accuracy, the method of approximating the relationship between color area ratio and angles with a polynomial equation should be revisited, and the multicolor marker detection algorithm should be improved. The following is the results of position verification. From left to right, x, y, and z. The average error was around 2 meters. Increasing the number of the markers may improve accuracy by smoothing the estimated shape, but the miniaturization of markers may reduce the accuracy of angular measurement. Now on, I would like to show you 3 applications. This is the first one, sensing motion of a caterpillar-inspired crawling robot. The proposed method was able to capture the robot moving by bending and compression. The second application is sensing fish swimming underwater. We thought that a proposed method could be used to target not only robots but also animals. The proposed method uses causal fin to capture movement through the water in the movie. The last application is sensing of fingers motion using a globe with markers attached. The shape of fingers bending in various directions was successfully measured. Finally, I will conclude the presentation. The following are the advantages of the proposed method. It can be measure multiple deformed shapes, and its simple design and RGB camera make it low cost. It is not limited to robots, but can also be used to measure various targets, including humans and animals. And the following future works are listed. Fabrication of robots with multicolored markers using a full-color 3D printer. Measurement of cell size target using micro markers and microscopes. And measurement of distant targets with telephoto lens. Thank you for listening.